Box extenders, or extension rings, come in a variety of sizes and shapes to match standard electrical boxes. They are shaped like boxes but have no back. They are designed to be installed onto the front of standard electrical boxes to increase the box capacity or to bring the box flush with the drywall or other surface material. The National Electrical Code, NEC, dictates that no wiring splices are allowed outside of an approved enclosure. Any standard outlet, switch box, or light fixture box can serve as an approved enclosure, but where a wiring splice needs to occur in other locations along the circuit, the approved enclosure is usually a junction box. A junction box is simply a standard electrical box that is mounted securely to house framing or another structure containing the connection or splice of two or more circuit cables. The cables are secured to the box with cable clamps or conduit connectors, if the circuit includes conduit, and the box must have a removable cover to create a complete enclosure. Junction box covers must remain accessible. They cannot be covered with drywall or other surface material. A junction box is most often used where an electrical circuit branches off in two or more directions from a location where an outlet or fixture is not practical. It is also a common solution when an electrical circuit is being extended. Make sure to buy a junction box appropriate for your installation. Outdoor locations, for example, require a weatherproof junction box with gaskets to prevent moisture intrusion. And make sure the junction box is large enough for the number of wiring connections you will be making. For example, the smallest 2x4 by 1.5 inch deep box can comfortably splice only 2 cables, 4 or 5 conducting wires, while the largest 4x4 by 2 1/8 inch deep boxes can handle as many as 4 to 6 cables, up to 18 individual conducting wires. For easy installation, many do-it-yourselfers choose the largest box that is practical for the application. A knockout is a partially stamped opening in electrical enclosures that allows quick entry of a wire, cable or pipe, via connector or fitting, to the interior. With the right information and technique, you should be able to remove a knockout from electrical panels and other electrical enclosures without any problems. Of course, ensure that the wires you're going to be dealing with are not powered. Switch off all suspect breakers and use a suitable meter or tester to ensure that power is off, reducing the chance of shock or burns. Locate the knockout stamping size to fit the desired connector or fitting. There will likely be several knockouts of different sizes on more than one surface from which to choose. Pick the one that will be easiest to connect the cable or pipe. Some switch boxes have slots in the knockouts for easy removal using a slotted screwdriver. These switch boxes usually have built-in clamps for securing the cable once entering the knockout location. Stay tuned to this site. The next nugget that I release will be a continuation of this video, where I will be diving into more detail of the essential rules. In the meantime, as a bonus and in the way of a thank you for your continued interest, I'm making available my 50-page electrical power crib sheets, if you haven't already taken advantage of downloading them. These were prepared for use with my courses. There is one section associated with each course, and are extremely valuable while viewing the course, as well as a recall of the pertinent formulas and information after the fact. The contained information is also useful during any technical career as a quick reference from time to time. Simply fill out the information requested when you go to this website. https://bit.ly/47y(b)3 and lastly h. As I said in the beginning, stay tuned for future releases on this site that will provide you with more tantalizing nuggets of what is available in my courses. You can also directly access my StanStore courses at this website. https://stan.store/g V B